Hello and welcome to the Immer Work Designer layout tutorial. In this part, we will take a look at some advanced functions of the Immer Work Designer. You will learn how to work with the rack configurator, how to export CAD data, and how to prepare objects regarding the coordinate origin and structure merge. As a basis, I brought you our training scenario. First, let's take a look at the rack configurator, which helps to create customized racks. In this example, I want to load a new rack to replace the small racks for the bearing covers and the ring bolts. To do this, I search for rack in the EMA object library. And load the object into the scene. Now the rack is in the 3D view and I'm going to position it. When the rack is selected, various parameters appear in the Objects tab in the parameter window to the right of the object tree. First, you can customize the color of the rack. Therefore, I choose a new color for the surface and the legs. I want the color to match the color of the other racks, so I take over its color with the pipette. Next, the size of the rack can be adjusted. The length and width are already suitable, but I will increase the stand width a little. The various rack levels can be defined in that lower area. The levels are arranged as if you were looking at the rack from the front. So in this case, there are levels at 1800 millimeters, at 1200 millimeters, and 600 millimeters. The angles and compartment length are not yet defined. I want to have a rack with 4 levels, so I change the heights to 1300 millimeters and 800 millimeters to have room for another level underneath. A new rack level can be added by clicking the button in the upper left corner. If you want to delete the newly added rack level, you can use the button at the upper right. This will remove always the lowest rack level. But we want to have 4 levels, so I add that level again, and it shall be placed at 300 millimeters. Here it is. The next thing we can do is to adjust the angle of inclination. The upper 2 levels are supposed to represent feed planes, so I specify a positive angle of 10 degrees for them. And the 2 lower levels are intended to function as return planes and are therefore given a negative angle of minus 10 degrees. Next, I want to add 2 compartments to the upper levels of the rack so that the existing small containers over here can be arranged in the rack. One compartment column is already available. The larger small container is to be placed in the upper compartment, so I enter 600 millimeters here. In the third level, I create a compartment for the other small container with 400 millimeters. A new compartment column can be added by clicking the button at the bottom left. Here we could add, for example, another compartment in the third level. Here it is. But since we only have 2 small containers, we don't need this additional compartment for now, and delete the column by clicking the button at the bottom right. It's also possible to change the rack compartment type from Kanban to rack levels. We want to have rack levels here. The last thing we want to do is to place the small containers on the rack. For this purpose, the layout helpers, align by reference object center and align by reference object top, can be used. The first step here is to select the object to be placed, in this case, a small container, and then select the layout helper. When the rack is selected as the target object, a dialog window appears that displays the various levels and compartments. The arrangement corresponds to the structure of the rack from the front view. By clicking on the different buttons, the small container is placed in the different levels and compartments. It's also possible to reset the object to the previous position. The larger small container should be placed in the 4th level. So I select the corresponding button and confirm with OK. The smaller small container should be placed in the compartment on level 3. So I select the container and the appropriate layout helper and select level 3. In the object tree, you can see that the small containers were automatically subordinated to the rack as child objects in the structure. In the last step, we delete the 2 old racks and arrange the newly loaded rack in their place. Well, this much about the functions of the rack configurator. To sum it up, we loaded a standard rack from the EBA library. We configured it by adjusting the parameters and adding new levels and compartments, and placed objects in it by the means of the layout helpers. Next, let's take a look at the export functions. In EMA Work Designer, both individual objects and complete layouts can be exported. To do this, we select our object and right-click on it in the 3D view or in the object tree to open its context menu. Under Creation, we select Save Active Object and File. Then the desired storage location can be selected and an object name including the file extension can be entered. The file types available, depending on the license, can be taken from the drop-down list below. I want to save the rack as a collada and therefore specify the extension .dae. Now the rack is exported and can be found as a separate file in my folder. If we now want to export the entire layout, we can do this by a click on the menu bar, on Import, Export, and Export CAD data. Again, we select the desired storage location and specify a file name and the appropriate file extension. The available file types can be again found in the drop-down list below. I want to save the layout here as STL and type in .stl. Now the exported layout is in my folder too. And with that, we have looked at the 2 options for CAD data export in EMA Work Designer. The EMA Work Designer also offers various options for object preparation. So let's look at how the coordinate origin of objects can be changed. To do this, we select an object, for example, this gearbox here, and right-click on it to open the object context menu. Under coordinate origin, the origin of another object can be taken by clicking on Apply Origin from Other Object. Therefore, you have to select a source object to adapt the origin. You can either select an object here or create a new marker at the desired position. In our example, we will use this empty Euro palette here. And now the coordinate origin of the gearbox is outside its geometry at the same position as the Europel's coordinate origin. In the object tree, you can see that the coordinate origin has been changed by the new symbol here. By opening the Object Context menu again and selecting Reset Object Origin, the newly selected coordinate origin can be reset and the original symbol appears again in the object tree. Further options to adjust the coordinate origin are to move the origin in the center of the bounding box, or to move the geometry so that the origin is at the center of the bounding box too. Another function in the context of object preparation is the merging of object structures. In Immer Work Designer, object structures can be simplified by merging subnodes. This can improve the performance of the simulation if you are working with very complex object structures. Thereby, only the geometries of the sub-objects are preserved. For example, the gearbox in the right container still has a complex structure. This structure can be reduced by a click on the 3D node of the gearbox to open the Object Context menu. And under Transformation, you can find Merge Object Structure. Please be aware that this function is not reversible. Now the gearbox has no substructure anymore and only the 3D node in the object tree and the outer geometry is left. We now have tried out different advanced functions of Immer Work Designer Layout, like the rack configurator, the export functions, and object preparation by changing the coordinate origin and merging substructures. With that, we come to the end of this part. Thank you for watching this tutorial. See you next time.